Okay, so 9.4 actually has a couple of different ideas that are probably going to be new to you. So we're going to talk about arc length and area of a sector. So just as a refresher, an arc of a circle is a portion of the circumference of the circle. So remember, you've learned about circumference in other math classes. That's the entire perimeter of the circle, okay? And so I want to kind of relate some of those words. But the length of the arc is simply the length of the portion of the circumference. And so you want to think of the circumference is C equals 2 times pi times your radius, or you might have learned it as pi times diameter, where pi is 3.14, okay? So because it is a portion of the entire circumference formula, you're going to see kind of a fraction formula or a ratio formula because that's the idea. So there's two different ways we're going to talk about the measurement though. All right, so the first way is we're going to introduce what you're used to. So in a circle, the degree measure of an arc is equal to the measure of the central angle and the arc that intercepts that. Okay, and so we have kind of a diagram here. So you want to think of, if I take my arc measure out of my whole circle 360, that's equal to my arc length over my circumference. So you kind of want to think of that. All right. So now if we solve this formula, because we don't want to set up a proportion every time, what we want to do is we want to get arc length alone. So if I would take and I would multiply both sides by my circumference, then we would end up with this formula. Okay. So we've got arc length equals the central angle, because that's related to the arc, out of 360, because that's going to give you that fraction of a circle. And then we're going to multiply it times the whole circumference. All right. So you don't need to really do fractions in your head or anything like that. All right. Let's look at an example. So if we have circle O, and I'm just going to go ahead and draw it, we've got a radius of 8, and you don't need a picture if you don't need it. And minor arc AB, so I'm just going to make this AB, is intercepted by a central angle of 110. All right, let's make this a little bigger so it looks kind of like what this picture is. So let's go ahead and just make A, and we'll just make B right here. All right. And so we've got the central angle, and then we have arc AB right there. And it says that the central angle is 110 degrees. Find the length of the minor arc, because it's less than 180, to the nearest integer. So we do want to round. So integer means kind of a whole number since it's positive. So we've got our arc length is equal to my central angle out of my whole circle, and then times circumference. So remember, circumference equals 2 times pi times radius, or you could do pi times diameter. It really, they're both equivalent, so you can use whichever one you want. I am so used to this one, so that's what I'm going to use. So 2 times pi times my radius, which is 8. Okay, so you're going to go ahead and just open up a new screen. And I'll open up my calculator, but you can just type this into a computer tab. All right, so we're going to do 110 divided by 360 times 2 times. Now, if you're using a calculator and you have a pi button, you should use that because that's the best value. If you don't, you can use 3.14, but you might be off, but you'll be really close. So 2 times pi times our radius. Okay, and you can type in, like I said, 3.14, 3.14159. There's lots of different suggestions, but the best way is if you have the pi button, type it in completely. All right, so I got 15.35. And it says to the nearest integer, so we're going to round down. So we want 15 inches. Now, on my quiz, I usually want you to go to 1 decimal place. If it's multiple choice, I'm going to give you these answers, but on a quiz, I do know some of you are using, for pi, you're using the button. Some of you are using 3.14. Some of you might get a better answer if you use 3.14159. As a general rule, I either want you to use the pi button if you can. I know not everybody has a calculator that has the pi button available, or use the 3.14, okay? I will accept either answer, just so you know. The best answer would be, or the exact answer would be if we leave pi in it, but that's a whole nother ball game. So we'll just go ahead and do this and follow the directions. All right, so that's with degrees. Now, I've alluded to this before when we did trig, but there is another unit of measurement besides degrees. Kind of like when you measure yourself, you can measure yourself in feet and inches, you can measure yourself in centimeters. There's different units of measurement. So for angles, all the way up until now, you've always known it's degrees. Triangle has 180 degrees, a circle has 360 degrees, but there's another unit of measurement, and it's called a radian. So a radian is just a different measurement. There is no symbol for a radian. There are some things you see that kind of signify it might be a radian, but typically it'll just actually either say radian or you're not going to have the degree symbol. All right. So what is a radian? So a radian, it's defined as the ratio of the length of the arc, and then it's divided by the radius of the circle. Okay. And so theta stands for our angle, just so you know. It's a Greek letter, theta. So theta, S, and I have no idea why they do this, but S stands for your arc length. It's never made sense to me, but I don't make these typical abbreviations up, divided by the length of the radius. So what we're going to end up with is our arc length is equal to the measure of the angle times the radius. Okay. Now, just to give you an idea, 1 radian is the central angle that subtends to the arc length of 1 radius. Okay, so since all circles are similar, 1 radius is the same value for all circles. And so if I think of this, and this is just a little brief overview, you'll do a lot more if you take secondary 3, but if I have a circle, I can think of 180 degrees is equal to 1 pi radians. So I could do 180 degrees, or that's 3.14 radians. Okay, so it's not a nice conversion. So typically a radian measurement will be a decimal, or you'll see the pi symbol in it. And that's kind of how you can signify that it is a radian. We really only use radian measure when we do trig, okay? If we're just talking about normal circles, you use degrees because that's what we're most familiar with, okay? And we don't have a protractor that measures in radians. All your protractors measure in degrees. So, but there are some uses when you get to Sec 3, when we draw graphs and things of trig functions, why we use radians. Okay, so it's not pointless, I promise. So just a few measurements, formulas, because this is kind of awkward and new. We've got, this is the formula for arc length if your angle is in degrees. And then if your angle is in radians, this is why we actually use it, is because we don't have to do any part of a circle. All right, so it's already, the radian is already converted for you. And so that's kind of its advantage. So we use it in trig graphing, and we use it in arc length. Okay, but we're going to do both. So let's look at this. First thing that you want to notice is my angle given in degrees? Is it given in radians? And so I noticed whenever you see a pi symbol, that should look a little different to you. And so that's telling you that that is a radian angle measurement. Okay. And so S equals, I always do R times theta. I don't know why, but that's how I was taught. So my arc length is equal to my radius, which is 13, times the measure of my angle, and this will be given to you. You will not be doing any converting in this class. You will do conversions in Sec 3. So my angle is pi over 6. So you really can say, with the pi symbol, you can leave that there. It's not a variable. Remember, pi is a number. But I can just make this as 13 over 6 pi. Or, let's go ahead and hit this again. I don't think this is going to be a nice answer, but 13 divided by 6. So it's 2.16 repeating pi. I could write that. Or if I use a decimal, we've got 13 divided by 6 times, and then we do need to use the pi button to get the most exact answer. It's still rounding, but it would be 6 point, and I'll just say 807. Okay, and so if you like to get kind of a sense of how big something is, you need to actually type in pi and use its value. Because 13 over 6 pi is kind of meaningless because we don't really grasp what size that is, okay? So I'm okay with the decimal answer. These are all three great answers. But first, I just want you to get comfortable with the formula for arc length, radians, and everything else. All right, so if that's the arc length, now something that's related is I can actually just take that little piece of pi and we can find its area. Okay, so remember, arc length is just this length on the circle, but then area of a sector is the area of that slice. Okay, and so we have some formulas. I would write these down. You're not expected to memorize these. We know from other courses that the area of a circle is pi r squared. So this should look familiar. See how I see pi r squared? And I kind of see it here. The pi is hidden in the angle though for radians, and then here's the r squared. And then this is the portion of the circle. All right, so let's do these two examples. Actually, I have three. So if I want a sector has a central angle, I'm just going to draw a picture in case you're a visual person, of 27 over 14 pi, and you can make this as big as you want. I'm just making it so I can actually write inside. That's my angle, okay? And a radius of 17. Find the area of the circle. So the first thing, I just want to figure out if my angle is in degrees or radian. So remember, anytime you see a pi, whoops, that is your hint that it's in a radian, okay? Which means we want to use this formula. So area equals 1/2 or 0.5 r squared times our angle. So I'll just type in 0.5. Our radius is 17, and then our angle. Okay. And I would say go to at least one decimal spot. I'm pretty flexible though. So let's see, 0.5. I'm going to type in 0.5 times 17 times, because it's squared. If you don't have a squared button, you can just type it in again. And then times, was it, I forgot, 27 over 14 pi times 27 divided by 14 times, and then I'm going to use my pi button. If you are using 3.14, your answer will not match mine, but I will understand. So that area is going to be 875.5. Go to one decimal place. And it's squared units. You don't have to put the label on it. Okay? And so getting the decimal gives you a sense of that. Let's look at my second example. They give us this little slice of the pie. The radius is 6, and my central angle is 36 degrees. So since that's in degrees, we're going to use that formula. So we're going to take our angle, 36, out of a whole circle, times pi, times our radius squared, so times 6 squared. I'm putting the squiggly because this isn't my exact answer, because I'm just going to get the decimal. So 36 divided by 360 times, I'm going to use my pi button, pi times 6 squared. So 6 times 6, or 6 and then the squared button. Okay? And so I got 11.3. And that's the area of that shaded region. It's not a very big one, not a very big circle, 6 inches. Okay. My last question says a sector has a radius of 10 and an area of 84 pi. So I'm going to say this. What is the measure in radians of the central angle? So we're going to use our formula in a different way. So since they want it in radians, I'm going to use the radian formula. So area equals 1/2 r squared theta. And we're going to substitute what we know. We know the area is 84 pi. We've got 1/2, and our radius is 10. And the central angle we don't know. If you don't like theta, we can just make this an x. Okay? So now what we need to do is we need to find the value of x. So you have a couple of choices. I'm going to go ahead and do this. So 10 squared is 100, and then half of 100 is 50. Okay? And since we're solving, I would divide by 50, and this doesn't go in evenly, but what you've noticed is when they give you our angle in radians, it's a fraction. So really it's best if you reduce this. If you struggle with reducing, then you can give me the decimal, but reducing is best. So if I divide these both by 2, I get 42 over 25, and then the pi stays. Notice when we had that before in radians, we saw a pi, and we saw a pi here. Let's see, 25 divides by 5, and that one doesn't. So this would be the size of the angle. Okay, and that's going to be kind of the best answer. If you give me a decimal, I'll accept it, but I prefer this answer.